Greetings and welcome. Today we're talking about applying trigonometric ratios. So far we've talked about being able to find their values. We know how to calculate them for negative angles and use coterminal angles and reference angles. We know when they're positive or negative in what quadrant. But today we're specifically going to kind of step away from the unit circle and go back to just straight up old triangles and talk about how we can use these ratios to solve triangles. All right, and what I mean by solve a triangle is typically to solve any triangle. Well, first of all, there's 6 pieces of valuable information for us in a triangle, which are going to be the 3 angles and the 3 sides. Okay, so in order to solve a triangle, you typically need 3 of the 6 pieces of information given in order to find the other 3 pieces of information. So suppose I've got this triangle P, R, and Q, or I guess P, Q, R, I don't know, whatever. And here's our information. Let's say I knew one of these acute angles was 35 degrees. And let's say I know that side little r is equal to 14. All right. So I want to point out I know 3 pieces of information about this triangle. I know 2 angles. One, because I knew this was a right angle. I knew one of the acute angles, and I know one of the sides. So what are the other 3 pieces of information I'm looking for? I'm looking for the measure of angle Q. I'm looking for the side P, and I'm looking for side little q. Right? So I'm looking for this side, and this angle, which I suspect is not the same as the other one. In fact, I'm certain of it. So I'm looking for those other pieces of information. That's what I mean by solve the triangle is tell me everything you know about it. All right. So let's look at this and try to figure out what we can do. So from this angle's perspective, let's label our sides. So this is the hypotenuse, and I know that because it's opposite of the right angle. And what would this side be? From the angle's perspective. That's the opposite leg, right? So OPP. And this one is touching one of the sides of the angle, so that must be the adjacent one. All right? So let's say I want to find this opposite side, okay? So let's look at what I know. If I'm looking for the opposite side, side P, all right, I know, or I can relate this to an angle and the hypotenuse. So I need to think about which of my trig ratios relate an angle, the hypotenuse, and the opposite. All right? So as I'm thinking about that, you might be considering the ideas of SOHCAHTOA, right? And you might realize that tangent relates opposite and adjacent. So that's I was all excited about that, but that's not what I was looking for. Sine is what relates opposite and hypotenuse. All right? So I'm going to just write an equation regarding that ratio. So I'm going to say that sine of the 35-degree angle is equal to my opposite, so that's side P, over the hypotenuse, which is 14. So if I want to solve this equation for P, what would I do? Yeah, multiply both sides by 14. And I'd end up getting the equation P is exactly equal to 14 times the sine of 35 degrees. Now, I don't know the sine of 35 degrees. I can't like put down my 35-degree finger because I don't have one between my pointer and my middle finger. But I can plug that in a calculator. So I'm going to just, first of all, you'd want to make sure that your calculator is in degree mode. And then I'm just going to do 14 times sine of 35. Now, sine of, actually, wait, I might even slow that down a little bit. Sine of 35, recall, this is just a ratio, right? Just like sine of 45 would have been the square root of 2 over 2. Sine of 35 is a ratio that's true all the time. So actually, I'm going to have one more step here. So 14, you won't have to write this step on your homework. I'm just writing it out right now. So sine of 35 is 0.5736. Yes. All right. And this ratio is true for all 35-degree angles, every one of them. And what this is saying is that the ratio of the opposite to the hypotenuse for a 35-degree angle is always 0.57. 736-ish. All right. So I can now just multiply 14 by that, and that's going to give me the side that I'm looking for. All right. So this is how I can put those to work. And I find out that P is equal to 8.03, and that's good enough. It's 0.07 after that, so I'll round to that. So I just found the value of length P, 8.03. All right. So, so that wasn't that bad. Let's say I want to find side Q now. Now, I could technically, you could argue, use the Pythagorean theorem. All right, because I know side 14, the hypotenuse, I know the opposite. So I know 2 out of 3 sides, and so I could find the third using Pythagorean theorem. However, I wouldn't, when possible, I'd recommend avoiding that, because this information, what if I made a mistake, and now I'm using my mistake to spread misinformation in finding my third side? So I always like to pull it back to my original information if possible. All right, so I'm going to use the hypotenuse, the part that was given, and the unknown adjacent that I'm looking for, right, and the angle that was given. So between those, what trig ratio relates to the adjacent and hypotenuse and an angle? Well, that would be cosine. So I'm going to just write an equation exactly as I see it. So I'm going to say that cosine of 35 degrees is equal to, and what's that going to be? Well, my adjacent is Q divided by the hypotenuse, which is 14. So to solve, I'm going to end up getting Q is equal to 14 times the cosine of 35. And as I said, that ratio is true all the time, right? So cosine 35, if I wanted to specifically find out what that is equal to 0.819 or 0.8192 roughly. So Q is approximately 14 times that, and I get 11.468. All right. Now, it's always a good idea, because it is actually easy to mix these up sometimes, because you don't always have to multiply by this. Sometimes it's dividing or vice versa. So it's always a good idea just to kind of check the reasonability of our answers. Actually, maybe I'll do that after I find the angle. Question, how could I find this angle? Okay, yes, all right. I almost disagreed with you for a minute, but I agree. So you're using triangle sum. You need that all 3 angles add to 180, so you add 90, 35, and subtract that from 180. That would work just fine. Or I could just subtract 35 from 90, because these 2 angles have to be complementary with one another. So those add up to 35. So 90 minus 35, what's that going to be, 55 degrees, I believe? Right. So, so what you should do once you get all of your answers is consider the reasonability of them. So for instance, notice 8.03 is opposite my smallest angle. All right, 14 is opposite my biggest angle, 90 degrees. And 11.468 is opposite my mediumest angle, 55 degrees. All right, so just use some reasonability at the end. Just be like, does this actually make sense? Right? For instance, if I found out an angle was like 200 degrees, I'd be like, I don't know about that. Right? I'd be kind of suspicious. So I just want to point out that that can be a good way to check your work. So here are my answers there. Right? And I've solved the triangle. I've found all of the missing sides. Now let me give you another example where it can be a little bit different. So let's say I've got a right triangle again. And I'll call this triangle A, B, C. And let's label some information. Let's say I happen to, in this case, what if I know this length is 10, and I know this angle is, I don't know, that looks like a 37-degree angle. And let's say I want to find this length x. All right, so I specifically want to find x. So find x is what I'll say for the directions. Find x. All right. So looking at this information, I have an angle. What is 10 compared to that angle's perspective? No. It's not touching one of the sides of the angle, so it's the opposite. And what is x? It's hypotenuse. Now, some people might say adjacent, which it is adjacent to the angle, but I do want to point out that technically adjacent and opposite are always referring to the legs of the triangle. All right, but x is opposite of the right angle, so it must be the hypotenuse. So what trig ratio compares opposite and hypotenuse for a given angle? Sine. So I'm going to say sine of 37 degrees is equal to, well, opposite over hypotenuse. So in this case, it's going to be a little bit trickier to solve. This is what I wanted to point out, that you don't just always multiply by the side you know. Like my answer is not going to be 10 times sine of 37 in this case. So question, how could I solve for x? Yeah, that's what I'm going to do. I like this idea. I multiply by x first because I don't like solving for a variable in a denominator. Technically, if you want to view this as some sort of rational equation I'm solving, I'm multiplying both sides by the least common denominator. But you don't have to think about it that crazy if you don't want. So I'd get that. And then to get x by itself, well, remember, sine of 37 is just a number. So to get rid of it being multiplied by x, I could just divide both sides by sine of 37. And this is where that ratio, which has been known for many, many, many years, centuries in fact, we can now find the length of the side. So 10 divided by sine of 37 degrees, I get 16.616. And now, does this make sense roughly in terms of my picture? I would argue, yeah, sure, I think so. It's longer than the 10, which is, based off the information I have, the hypotenuse should be longer than the other side.
What was sine of 37 degrees? Did you do that on your calculator?
Yeah, I just typed it all in my calculator all at once. Let's see. So I just entered it like this.
You do it just like that?
Yeah.
Okay.
But if I wanted to specifically find out what sine of 37 was, that's the ratio. And one of the things I want to point out regarding sine and cosine, their values are always between -1 and +1 for any angle. For angles in your first quadrant, they're always going to be between 0 and 1. But do you have a question?
Yeah. What's the acronym again for that?
SOHCAHTOA. SOHCAHTOA. All right. And one of the things I want to point out is if I did 10 times the sine of 37, all right, say I did this problem wrong, I would have gotten 6.0182 for my side length. And why would have I immediately known that was wrong? Why is 6 not making sense for this picture?
Because the hypotenuse is shorter than on the left.
Right. So if you make a mistake, usually you can immediately realize it. So just be aware of that. Usually you could try to figure that out. So sometimes you're going to be dividing, sometimes you're multiplying, doing all sorts of different things. But the key is you literally just set up the ratio as you would have originally suspected, right? I knew that sine of theta is equal to the opposite leg over the hypotenuse. And I just knew that ratio, I plugged in everything I knew, and I solved for what I didn't know. All right, let's do one last example, which is going to be a tricky one, combining some of our previous skills from the very first thing we learned in this course. So here's an example. The directions are going to be find the height of the mountain. The mountain, yes. So I'm going to draw a picture here. My excellent artistic ability. So I'm going to draw this awesome mountain. All right, here's this cool, jagged mountain, and it's got like snow on it. There it is. Look at that. And maybe there's like a little village down below. And they're like, oh no, don't avalanche on us. I don't know, right? And all sorts of stuff like that. Okay, so let's say, now I don't know if you realize this, finding the height of a mountain, it would be difficult to drill from the peak of the mountain all the way down to its base and then like drop a ruler down and be like, found it, right? Like that would be a lot of work. And I don't know if you realize this, but that is not what people have done for many, many years in calculating the heights of objects. All right. But I think you guys do agree that maybe I'll pick a different color here. Maybe I'll draw my triangle in green. So that is the dimension that I'm looking for, the height. And this is the trick that one of the tricks that mathematicians have used, right? We know that the height is a 90-degree angle, right? So the perpendicular. And what we could do is we could actually say there's two villages, all right? Or this is where you live and here's your buddy's house. And you guys are going to help each other out. So from your house, looking up at the peak of the mountain, all right, you're able to calculate an angle. And from your buddy's house, looking up at the peak of the mountain, he would calculate a different angle. That was a sad drawing. That's good enough. That's not even a line, but we'll pretend. So he'd calculate a different angle. Question, actually. We'll label these points. Let's call this, I don't know, A and B. So whose angle would be larger? Point A or point B's angle? A would be larger, right? That's going to be a bigger angle because you have to tip your neck back like at a movie theater in the front row, right? Whereas your friend doesn't have to do that quite as much to analyze the peak of the mountain. Okay, so let's say from your perspective, angle A is equal to 40 degrees, 30 minutes. And angle B, measure of angle B, is equal to 37 degrees, 46 minutes. Okay, so both of you have some sort of tool to measure that, some sort of plumb bob, sort of surveying tools. We actually could even construct that with a protractor, a piece of string, and a rock if we wanted to. All sorts of ways you can do that. There's more accurate ones with lasers now and all sorts of cool things. So you're able to measure those two angles, all right? And that's what we find. The other thing that you could measure, let's say you know the distance between your houses is 1,000 feet. That's 1,000 feet. All right, so AB is equal to 1,000. And we're interested in h, the height. Now, another dimension that will be helpful to know or to not know in this case is your distance to where the center of the height would land, right? And that's an unknown distance to us as well. So I've got the height that I want to know, I've got this unknown dimension, I've got 1,000 feet, and let's see if we can figure out some relationships and solve this. So unfortunately I have two unknowns, but I also can actually have multiple equations to help us out. Now, let's look at just your smaller triangle for starters. We know your angle, and I have two sides. All right, this side is the opposite from your angle, and x is the, what leg is that? Adjacent, right? So the trig ratio that compares those things would be tangent. So I could say, actually, well, let's first of all maybe convert this angle to degrees. 40 degrees, 30 minutes is going to be the same as what? 40.5 degrees? You guys agree? And 37 degrees, 46 minutes. How would I convert that 46 to degrees? Yeah, divide by 60. So that's the same as 0.76. So that's 37.7. I'll round it up to 7 degrees. All right. So I'm going to say that tangent of 40.5 degrees is equal to h over x. So that's one equation I could write with two unknowns. Now, considering back to our chapter on systems and matrices and Kramers, you might recall that if I'm trying to solve for two unknowns, I need two equations. So let's analyze this from your friend's triangle. It's a gross triangle. He's got the same opposite side, right, h. And his adjacent leg is going to be this total distance. What's a way I could represent that total distance? Right, that total distance is x plus 1,000 or 1,000 plus x. And that's also the adjacent. So that's going to be tangent, comparing opposite over adjacent. So from his perspective, we'll have tangent of 37.77 degrees is equal to h over x plus 1,000. All right, and notice what I have now is just a system of two equations and two unknowns. I wonder what one we should start with. Let's solve this one for h. Okay? So to solve this for h, what would I do to both sides? Yeah, multiply by x. And I'd end up with h equals x times tan of 40.5. And I'm actually going to leave that in terms of its exact calculation, hopefully until the very end. We'll see if I'm able to do that. So that's what h is equal to. So now what I want to point out is I could actually now substitute this over here for h, right?
Mm-hmm.
I think so. So that would give me tan of 37.77 degrees. And this isn't the only way you could solve this. I also could have started over there, or I could have solved for x first. I don't know, that might have been more helpful, who knows. So that's I'm gonna replace this h with x times tan of 40.5, all divided by x plus 1,000. And in order to solve this, notice I have one equation. It's kind of ugly. It's going to require Chapter 9 from Math 3/Algebra 2 to solve because it's a rational equation. But there's only one variable. All right, there's only an x. All right. So the first thing I'm going to do is get rid of this denominator. I'm going to multiply both sides by x plus 1,000, which is my LCD, least common denominator between all of the fractions in this problem. All right, and I think you guys would agree that this over here would just cancel with that, right? Which is good news for us. Hooray. Yes. And what I have over here, I'd have to distribute. So I'd have x, let's see, do I have the right color selected? Here we are. X times tan of 37.77 degrees plus 1,000 times tan of that is equal to x times tan of 40.5 degrees. Now, we've got two x's. All right, imagine if this equation was simpler. What if this just said 2x plus 1 equals x? All right, imagine it just said that, because this is just a number, this is just a number, this is just a number. What would we do to get the x's together? Not quite, not yet. First, I'd have to bring the x's together before I start dividing. Yeah, you could move the 2x over here by subtracting 2x, right? You could move this x over here, but then you'd have to move the 1 to the other side. But yeah, I'm just going to bring the x's together, and that's the same thing I'm going to do here. In this case, I'll move this one over here so I don't have to move two things. I don't know, sounds good to me. So I'm going to subtract this x tan of 37.77 from both sides. And I will have, let's see, 1,000 times, you guys are going to be sick of writing 37.77 by the end of this, equals x times tan of 40.5 minus x times tan of 7.77. Now we're warmer. Does anyone know how to write this as a single x? Anyone know what I'm doing? Yeah, GCF. Because these are both just plain old x's, it's not like a quadratic or anything, I can just factor it out. And I'll have the same thing on this side. I'll just write ditto marks over there for now. and I'll have x times, and what would be left? Tan of 40.5 minus tan of 37.77. And now notice I've got x multiplied by this thing. How do I get rid of this thing? This is just some number. Well, a calculator would give me the number, but how would I actually get rid of it? If this said 3x, how would I get x by itself? Divide, right? So I'm going to divide both sides by this big ugly thing, and I'm going to get x equals, all right, this would have been, my numerator is 1,000 times tan of 37.77 divided by this big ugly thing, tan of 40.5 degrees minus tan of 37.77. All right, so all I've done is I've solved a system for one of its variables. I mean, it looked weird because it's got all these tangents floating around, but just remember, those are just numbers, all right? So let's actually find out what x is approximately. And I want to point out that this denominator, I'm going to have to be really careful plugging in. It's going to have parentheses. So let's see if I can do this. So on my calculator, turn this on, bam. My numerator was 1,000 times tangent of, let's see, what was it, 37.77? Was that the correct? Yep. And I'm going to have to close this parentheses this time and then hit divide. And before I put in my denominator, I just want to point out this whole thing has to be my denominator, so I'm going to have to open up another set of parentheses. All right. And I'll do tan of 40.5, close that little parentheses, right? And then minus tan of 37.77. And close that parentheses, and then the big parentheses for that denominator. All right, so I technically had to have double closed parentheses there. So it's all, order of operations is kind of the tricky part of plugging this in. So I hit enter, and I hit 9778.475. And that's measured in feet, according to our problem. And to bring that back up in terms of the problem, all I've calculated was x here. I'm looking for h. If I was solving this as a system, well, I actually have my revised equation right here, so I can just plug x back into that and solve for h. So it's just going to, h is going to equal x that I just found multiplied by tan of 40.5. So I can do h equals 9778.475 times tan of, was that 40, I short-term memory here. What was it? 40.5, that's what it was. All right, so that will be my approximation for h, the height of the mountain, a la montaña. And let's see, so multiply by tan of 40.5, and I get 8351.607. 8351. And so I was able to calculate the height of the mountain. Now maybe I could have done it a little bit quicker if I maybe started by solving for x and then got h, you know, right away if I substitute for x rather than h at the beginning, but it doesn't really matter. But the point is you can use trigonometry, systems of equations, all sorts of stuff, kind of combine some of our skills to be able to answer a question as complicated as this. All right, and the idea was representing this as multiple triangles because that problem, although it took a bit of time, it was quicker doing that than it would have been drilling down through the center of the mountain to actually measure the height, right? At least I imagine, right? So all sorts of cool stuff that we can do with trigonometry. Later on, we'll actually end up being able to find and solve triangles rather that are non-right triangles. We'll have all sorts of cool strategies. But the idea behind solving triangles is of the 6 pieces of information, you have to start with 3 to find the remaining 3. All right, thanks for watching, Internet friends. Bye-bye.